What is our purpose? Who put us here? Are aliens real? Is the writer for The Simpsons a time traveler? The universe is a weird and twisted place, and there are so many questions that are left unanswered. Hi, I am Slit McDouble, CEO of Wave Function Industries. Here at Wave Function, we are interested in a mysterious question that has been asked by quantum physicists for decades. Today at Wave Function, we're going to be talking about the famous double slit experiment. Quantum physicists are interested in answering if tiny molecules of mass, such as an electron or a photon in the quantum world, act as particles or waves. So, what's the answer? Do they act as particles or waves? Well, the answer to that question is yes. Let me explain. So let's start off by defining the differences between particles and waves. A particle is a finite object in which we can point at and say that that is a particle. I'm a particle. For a particle, we can hold it, throw it, and define its precise position. Particles also travel in a straight line and can collide with other particles to change its trajectory. A wave, on the other hand, is almost the complete opposite of what we consider a particle. For a wave, we cannot hold it, interact with it in any way, and we cannot define its precise position. Waves, however, can interact with other waves, creating peaks and valleys of various energy by adding or subtracting energy from each other. Once you have defined whether your object is a particle or a wave, you can then assign the correct formulas to help solve for the various mathematical traits, as they both have different sets of equations. So, let's now transfer our new knowledge to the double slit experiment. Oh hey guys, I'm the Filipino Gordon Ramsay if you were a scientist.
What are you?
An idiot sandwich.
Chefing it up here at Wave Function Kitchen. Let's first take a look at how particles behave with a double slit. To demonstrate how particles will act through a double slit, I will use this bag of oats and pour it through the two slits. As we pour the oats through the two slits, we can see how it is starting to form two separate mounds with the smaller amount of particles found outside of the region that is directly under the slits. This is what is expected when you shoot particles through the two slits. Now, let's take a look at how waves will act when they are faced with the double slits. The wave will approach the two slits and will break into two separate waves originating from each individual slit, resulting in two separate wave patterns. These two wave patterns will interact with each other, creating an interference pattern with multiple regions of high probability of where the wave will hit the screen behind the slits, resulting in this pattern. So, in theory, it should be pretty easy to decide whether or not these molecules act as particles or waves, right? We just shoot them through the double slit. If they result in this, they're a particle. And if they result in this pattern, they're a wave. How hard can it be? Wrong! No, that is not how the universe works. It is the beginning of the 20th century. Quantum physicists have decided to proceed with this exact experiment. They decided to shoot electrons, which are tiny pieces of matter, towards the double slit. To their understanding, the electron should act like a particle and produce the same two mounds that are formed by the oats. But the results surprised physicists across the globe. The electrons produced an interference pattern when they hit the screen, which is produced by waves. But how can little particles of matter behave as a wave? Maybe they're interacting with themselves? The physicists then decided to shoot the electrons one by one. Surely it should form two mounds. There is no interaction with other particles. After some time, the interference pattern formed again. The electron interacts with itself before going through the double slit. An electron behaves as a wave. Or so they thought. So the physicists wanted to become a little more sneaky. How about we detect and observe which slit the electron passes through? Let's set up a device that will detect the amount of electrons that pass through each slit, as we are able to detect particles of matter. So the device was set up, and the pattern that was formed, it's the particle pattern. What? The simple act of observation destroyed the wave pattern, resulting in the electron to become a particle once again, resulting in this particle pattern. So this is what we call wave-particle duality. Small objects down in the quantum world can act and behave as waves and particles at the same time. So there are a lot of other experiments related to this topic that are being done right now. And that is what us here at Wave Function Industries are going to help solve. I am Slit McDouble, and I hope you enjoyed this video. Make sure to stay curious. Wave Function, bringing the quantum world to you.